Chapter 13, Lesson 3, Least Common Multiple. This is quite the opposite of what we did yesterday. Yesterday with factors, we found numbers that were, when we multiply them together, we get something else. This is that something else. Okay, we're finding multiples. And what is a multiple? A multiple is a product of two whole numbers. Okay, the answer, and by the way, the answer to a multiplication problem is a product. So what I'm asking you to do here is list the first 10 multiples of 8, 15, and 4. So go ahead and list the first 10 multiples. And when you start here, ladies and gentlemen, when you start here, make sure you list 8 there. So go ahead and give the video a pause, try it, and see how you did. If these are the numbers that you came up with, you are absolutely correct. 15 was probably the hardest one for you, would be my guess. But hopefully you made it through. Couple talking points. So what's the difference between a multiple and a factor? Well, if you look here, multiple, okay, some words that we were trying to get stuck in your head here. They're mega, they're multiple, and they're massive. Why? Because multiples go on forever and ever and ever. It is like the song that never ends. Yes, it goes on and on, my friends. Some people started singing it not knowing what it was, and they'll continue singing it forever just because it's a song. You get the idea. Multiples go on forever. Factors stop. They stop. There's an exact number of factors. For every number has an exact number of factors. Multiples, like I said, go on forever. So the smallest, think of it this way, the smallest multiple of 8 is 8. The largest factor of 8 is 8. So that kind of sums it up right there for you. Okay. So let's figure out how to find the least common multiple. Now, some questions may arise. How many multiples do I list? Well, look at the other number. It'll tell you. Okay. So that's step one of the things to do. Step 2 is to find the smallest number that they have in common. So again, step 1, how many do I list? Well, I look at the other number. So I list the first 4 multiples of 3. Got 4. I'm talking and writing at the same time. Doesn't work very well. 3, 6, 9, and 12. So then I list the first 3 multiples of 4. 4, 8, and 12. And what is the smallest number they have in common? You got it right. 12 is the smallest number that they have in common. Again, all I did was, how many do I list? I look at the other number. I listed the first 4 multiples of 3, and I listed the first 3 multiples of 4. Because worst case scenario, the LCM is in fact the product of the two numbers, 3 and 4. Now, does it always happen like that? No, but sometimes it does. Alright, so go ahead and let's list the multiples of 7. 7, 14. While you're doing this, you get a nice review of all those basic facts you learned way back in 3rd grade. Hopefully you're keeping up with me. And hopefully you don't have to use me for help. So 9, 18, 27, 36, 45. Would be good if you get stuck on these. Would be a great place to look. You guessed it. Your planner would be a great place to look for help when messing with those basic facts. So 63 is the smallest number that they have in common. 63 is the smallest number they have in common. So you try 8 and 12. And let's see what you come up with. If your answer was 24, then you are correct. Now you'll notice that they have 48 in common, they have 72 in common, they also have 96 in common. Yes, but again, the least common multiple means the smallest number that they have in common. So here we have another way to find the least common multiple. This is a factor tree. Now you remember factor tree from yesterday. Now we're going to use the factor tree, but we're not going to use it in the exact same way. Okay, excuse my pen; it's being awfully stubborn right now. So how this works. Okay, the factor tree works the exact same way. So the 3 and the 5. Alright, because of the technical difficulties with the pen, I went ahead and typed it in so you wouldn't have to
to wait for me. So 3 times 5 does give me 15. I can't break 3 down any further, can't break 5 down any further. 8, 2 times 4, 2, can't break it down any further. 4 can break down to 2 and 2. So what I have here is 3 times 5, and I also have 2 times 2 times 2. 3 times 5 gives me 15, 2 times 2 times 2 gives me 8. Now, how in the world do I use these numbers to find the least common multiple? But here's what I do. I find where's the largest number of 2's. Well, the largest number of 2's is right here. So 2. 2 times 2 times 2. I've got, where's the largest number of 3's? Well, they're right there. So times 3. And where's the largest number of 5's? Well, it's up there. There's 1 5, so times 5. So all I did was I looked for each number that's represented here. So 2, 3, and 5. And where is the largest number? So really, what I have here is 8, 24, 24 times 5, which is 120. So when I multiply all those numbers together, that gives me the least common multiple, which is 120. So again, this was one of those worst case scenarios where the LCM is in fact the product of the two numbers. So go ahead and give the video a pause. I want you to try 8 and 12. If this is what you had for your factor trees, 3 and 4, and then 4 breaks down to 2 and 2, and then 8, all I had to do was look over here and copy. That's a way to use the problem to help you solve the problem. Now, here's what I have. 12 is 2 times 2 times 3. 8 is 2 times 2 times 2. So really all I have are 2's and 3's. Where are the most 2's? Well, the most 2's are right here. And I've got 3. 1, 2, 3. Where are the most 3's? The most 3's are right here, and there's only 1. So that's why there's only 1 3 there. So 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. So the LCM of 12 and 8 is 24. Now if you remember back here, we did the same thing with listing my factors, and I got the same answer. So I know I'm good to go. So here is your bell work tomorrow at school. So good luck, and we'll see you tomorrow at school.